Okay, good afternoon, everyone. Today we will have a lecture on that is mechanics, engineering mechanics. So we will see the different concepts regarding engineering mechanics because the most important bit related with engineering mechanics because in a number of question papers there will be some of the bits related with the engineering mechanics. It has been asked in the GATE exams also. So we will go through the different concepts of engineering mechanics. We will take care of the engineering mechanics, the different concepts related with the engineering mechanics. So how much weightage will be there, we will see, and what are the different questions it has been asked. We will take care of all this. Okay, so we will go through all these things. First of all, we will go through the definitions of engineering mechanics. So what is engineering mechanics? Actually, it is a branch of physics in which it deals with the forces acting on a body when it is at rest or when it is in motions. Okay? When the different forces are acting on a body. Okay? So in nature, you can observe the different forces. You can have you can as you take care of the different forces which has been acting on a body. The chair on which you are sitting, or the table or the chair or the different things which has been there, the different forces it has been acting on a body. So we have to find out the effect of that forces. Okay, what is that effect of that forces on a body? Okay, when it is in motion or when it is in rest. So this mechanics, it has been broadly classified into various things. So classifications of mechanics is there. What are the different things in which it has been classified? So we'll see one by one the different concepts regarding with the engineering mechanics. First, engineering mechanics, it has been classified as the mechanics of solid and mechanics of fluids. Okay, so in mechanics of solids, it has been stated as mechanics of rigid bodies and mechanics of deformable bodies. Okay, so it may be moving bodies as well as the deformable bodies. Okay, so mechanics of rigid bodies, mechanics of deformable bodies. Rigid bodies, when there is no as such effect of the forces on a body. Okay? Deformable bodies, when there is change of the shape of the body. Okay? So again, mechanics of rigid bodies, it has been divided into two. That is the statics and dynamics, and there is mechanics of deformable bodies. It is again divided into two. That is nothing but the theories of plastic elasticity and theory of plasticity. Okay, so in this, what is statics and what is dynamics? Mechanics of rigid bodies. May we will see about the statics and dynamics. So what is statics and what is dynamics? Statics are when the forces acting on a body when it is at rest. Okay, na? When the forces acting on a body when it is at rest, so we will cover. It has been taken care in the statics. Okay. What about the dynamics? So when the forces are acting on a body when it is in motions. Okay, so when there is a body in motion, so what is the effect of the forces on a body? Okay, when it is in motions. Okay, so what is kinematics and kinetics? While considering the forces causing the motion, it is kinetics, and without considering the forces is kinematics. Okay, again, it has been divided as mechanics of deformable bodies is nothing but the theory of elasticities and theories of plasticity. Because in your there is mechanics, we will study up to this kinetics, because this part is somewhat different part is there. Mechanics of deformable bodies is somewhat different part is there, so it will not be taken care. Okay, what is mechanics of fluids? Again, there is the different types of fluids are there. That is ideal fluid, viscous fluid, and the incompressible fluids. Again, this is not a part of our study, because we will study totally deals with the engineering mechanics. That is, we will take care of this kinetics and kinematics. Up to this left side part, we will try to cover. Okay. Next, what is mechanics of deformable bodies? What is mechanics of deformable bodies? The mechanics of a deformable bodies deals with how forces are distributed inside bodies. That means how is the position or how the forces that has been distributed within the bodies, inside the bodies, and with the deformation caused by these internal forces force distributions. That means what is the pattern of the forces inside the body, and what is the effect of these forces on the body, what is the effect of the forces on the body, okay, with the forces causing deformation in the body, okay. So these internal forces produces stresses in the body, which cause ultimate, that is result in the failure of the material itself. That means finally, due to these forces, stresses will be developed in the body, and which will results in the failure of the material. That is, the body will fail because of the stresses which has been produced inside the body. Okay, na? Again, what is the principles of rigid body mechanisms? Often provides the beginning steps in analyzing these internal stresses and resulting deformations. That means rigid bodies, again, it has been used for analyzing of these internal stresses, and which results in the deformations, okay, resulting into the deformation. That means our main aim it is to find out the effect of internal forces on a body, okay. What is the effect of forces on a body? Because mechanics, it is totally deals with the effect of forces on a body, okay. So these will be studied in the courses such as strength of material and the mechanics of materials, or mechanics of material, okay. Again, what is mechanics of fluid? We will in a fast we will see what is mechanics of fluids. The mechanics of fluid is the branch of mechanics that deals with the liquids or gases. That means what is the effect of liquid, one of the different forces acting on a liquid, or the different forces acting in the gaseous state, okay, na? The fluids are commonly used in engineering applications. They can be classified into as incompressible or compressible fluids. While all real fluids are compressible to some degrees, most liquids can be analyzed as an incompressible in any in many engineering applications. That means most of the fluids in the real fluids, it has been considered as a compressible. Okay, okay, compressible fluids it has been considered. Next, what is the study of the mechanics of fluid will be it will be studied in the courses such as fluid mechanics or compressible flow, hydraulics, and others. In the subjects, we will it deals with the mechanics of fluid. That means the forces acting on a fluid. So it will be studied in this fluid mechanics or compressible flow or hydraulics and other things. Okay. Next is mechanics of rigid bodies. Mechanics of rigid bodies. It deals with a rigid body is a body which does not deform under the influence of forces. Again, this rigid word relates with there is no effect of the forces on a body. ठीक है ना? There is no as such effect of the forces on a body. तो क्या है rigid body? क्या? A rigid body is a body which does not deform under the influence of forces. Is nothing but the rigid body. ठीक है ना? So there is no effect of forces on the body. Is nothing but the rigid body. ठीक है? A rigid body is a body which does not deform under the influence of the forces. In all real applications, it is nothing but there is always deformations. However, many structures exhibit very small deformations under the normal loading conditions, and rigid body mechanisms can be used with sufficient accuracy in those cases. That means every body will have somewhat deformations. There is no as such ideal bodies there, okay? Because every body will have some deformations, and we will study the effect of this forces on the body, okay na? So ये सारी चीजें we will study in this, okay? Next, what is the fundamentals of this? Next is nothing but the fundamentals. What are the different fundamentals related with the mechanics? What are the different important concepts, fundamentals related with the mechanics? We will see the laws also. So, what are the fundamentals of the mechanics? Number one is nothing but the length. ठीक है? तो length क्या है? देखो, length is the quantity used to describe the position that is of a point in space relative to another point. That means length will decide or will exhibit the positions. Okay? Positions. You can, the length is a quantity used to describe the position of a point in space related to one another. So yeah, that means what is the distance between the 2 points. So this will be identified by a length. The length will decide the distance between the 2 points. Okay? So this is nothing but the length. Okay? Next is time. Time is the interval between the two events. Wait a minute. So what is time? Time is the interval between two events. The general uh, the generally accepted standard unit of time is the seconds. Normally, time it has been measured in seconds, and time is nothing but the interval between the two events. What is the lapse? That is the time interval between the two events. Okay. Next is space. What is space? The geometric region in which the study of body is involved is called as the space. The region in which we will study the concept of the body. ठीक है ना? The different forces acting on a body. The region in which the force is acting on a body. This is nothing but the space. Okay. Space is nothing but the geometric region in which the study of the body is involved is called as a space. Next, what is displacement? Displacement is it is defined as the distance. Displacement is nothing but the distance as moved by a body or a particle in a specific directions. Distance क्या होता है? The specific directions में movement हो रहा है. That is nothing but the it has been it is nothing but the displacements. ठीक है? Next is velocity. Again, velocity is an important concept related with this. What is velocity? Velocity, it is the rate of change of displacement with respect to time. All these are the basics that are related with the mechanics because all these fundamentals, it has been used to solve the numericals related with the mechanics. So therefore, this it is very very important concept we have to study. So next is nothing but the velocity. Okay? Next is nothing but the velocity. Velocity, it is the rate of change of displacement with respect to time. That means there is change of displacement with respect to time. It has been measured as a velocity. What is the unit of velocity? Meter per second. Okay. Next is accelerations. It is the rate of change of velocity with respect to time. Again, the velocity with respect to time is nothing but the accelerations. Next is momentum. The product of mass and velocity is called as a momentum. It has been expressed momentum. It is nothing but the product of mass as well as the velocities. Yeah? mv is nothing but the momentum. Okay. Continuum. A body consists of several matters. Is nothing but a continuum. Particle क्या रहेगा? What is particle? A particle may be defined as an object which has only mass and no size. That means mass it has been considered, but there is no as such size available. ठीक है? So is nothing but a particle. The particle may be defined as an object which has only mass and there is no size of it. ठीक है ना? There is no size. Such a body cannot exist theoretically because every there is particle or every there is object, it will have some size. ठीक है? So therefore, such a body cannot exist theoretically. However, in dealing with problems involving distances considerably large compared to the size of the body may be treated as a particle. Okay? Next important we will consider related with engineering mechanics is nothing but the vectors and scalars quantities. ठीक है ना? So this vector and scalar quantity is also very important related with the mechanics because in some cases some of the numericals we use the vector quantities and scalar quantities. ठीक है? So we have to go through the basics regarding what is a vector quantities and a scalar quantity. ठीक है? So all the physical quantities, that is speed and force, are described as a magnitude and a unit. That means it will have the magnitude and it will have a unit of it. Okay. What is a vector quantity? Vectors are also need to have their directions. That means it will have some directions. It will have its magnitude as well as the directions. Vector quantity will have the magnitude as well as the directions is nothing but the vector quantities. What are the examples for this? Which is having directions as well as magnitude is nothing but the displacement, velocity, accelerations, force are the some of the there is examples for the vectors quantity. Next, what is the scalar quantities? Scalars do not have directions. That means it will have only the magnitude. Okay? Magnitude. It will not have the directions. Okay? So only magnitude will be considered for the scalars. Okay? In scalar quantities, only magnitude will be considered. Okay? So is nothing but the scalar quantities. So scalars do not have directions. That is the examples is nothing but the distance, speed, mass, work, energy. These are the examples for the scalar quantities. Okay? These are the examples related with the scalar quantities. Next is how we can add additions of the two vectors. Okay? The additions of vectors with the two vectors acting at an angle to each other's. That means there are two vectors which is making an angle of 90 degrees. So what is the how it can be added? Okay? How it can be added? So here it has been taken as this in horizontal directions. It is moving right side. It is having a intensity or magnitude of 4 newtons, whereas this is moving vertically downwards. Okay? And 3 newtons. So how it has been added? So it has been added in this form because this is parallel to this. So we can have in rightward positions, but here we can shift this to this point so that it can be added. Okay? So these 3 newtons will be shifted to this right side, and by Pythagoras theorems we can easily find out the resultant. And some of the opposite sides and hypotenuse square and opposite square with all this we can easily find out the hypotenuse. That is the resultant for this vectors. Okay? There is a simple by concept we can find out this. Okay? Next is most important is how it has been comparison between the mass and the weight. Okay? Because these two are the different things are there. This mass as well as weight. Okay? What is the comparison between the mass and weight? So first of all, mass is a property of a matter. That means mass, it is nothing but a matter which has been considered. The mass of an object is the same everywhere. Mass will always be same everywhere. Okay, now mass will not be changed as the distances changes. The mass will not be changed. The mass will be same at everywhere. Okay, na? What about the weight? Weight क्या रहेगा? आप देखो, weight depends on the effect of gravity. That means it depends upon the gravity. You know, gravity. ठीक है ना? It will be changes. It will not be same. The weight varies according to the locations where the distances changes at the same time with this. So weight will also be changed. ठीक है ना? The weight varies according to the locations, according to the distances. ठीक है ना? The weight varies according to the locations. But here mass it has been same at every point. Okay? Number two is nothing but mass can never be zero, whereas weight can be zero. Mass cannot be zero, or weight can be zero. So if no gravity acts upon an body, upon a body or on an object, as in space, then at that time we can have a weight as zero also. Okay? The best example is in the space. We can have the value of zero in the space. There is no weight in the space. Okay? Number third point is nothing but related with the comparison is mass does not change according to locations, as it is everywhere it is same. The same way first and third point is somewhat similar. The mass does not change according to locations, whereas weight increases or decreases with higher or lower gravity. That means it will be dependent on gravity. ठीक है ना? तो gravity पे depend करेगा. Weight increases and decreases depending upon the gravities. ठीक है? Number fourth point is nothing but mass is scalar quantity. It has a magnitude as well as weight is a vector quantity. In previous slide, we have seen what is a scalar quantity and what is a vector quantity. You can, so in the same way, mass is a scalar quantity because it is having only the magnitude. There is no directions of mass. Okay. What about the weight? Weight is having a magnitude as well as directions. Okay. So it has a magnitude and its directions directed towards the center of the earth or other gravity wells. Next is nothing but fifth point is mass can be measured using the ordinary balance, whereas weight is measured using a spring balance. Okay? The apparatus used to measure mass is ordinary balancing equipment, so we can measure the mass, but weight can be measured with a spring balance only. Okay? Mass usually is measured in grams and kilograms, whereas weight is measured in newtons. Okay? Now, weight is measured in newtons. Mass is measured in kilograms, grams or kilograms, but weight is also always measured in the newtons, a unit of force. Next is again there is an important comparison between the distance and the displacement. The because these are the similar terms, it is similar, and weight, mass, distance, displacement. So this difference is very very important. What is the difference between the two? It has been very very important. Okay, na? So next is nothing but the distance and displacement. So what is distance? Distance is the length of the path traveled by body while moving from an initial position to a final position. Okay? So distance क्या होता है? It is nothing but the traveling from one point to the another point from starting position to the final positions. The distance traveled is the length is nothing but the distance. Okay? अब डिस्प्लेसमेंट क्या होगा? देखो, डिस्प्लेसमेंट इज द शॉर्टेस्ट डिस्टेंस बिटवीन द इनिशियल पोजीशन एंड द फाइनल पोजीशन ऑफ द बॉडी. अभी क्या है? देखो, लेंथ है ना, बट डिस्प्लेसमेंट इज नथिंग बट द शॉर्टेस्ट डिस्टेंस. इट इज नथिंग बट द शॉर्टेस्ट डिस्टेंस. What is number two? Number two is distance is a scalar quantity. Again, displacement is a vector quantity. As in the previous we have seen mass about the mass and weight. The same way, distance is a scalar quantity because it is having only the magnitude. It doesn't have the directions. Therefore, distance is a scalar quantity, whereas displacement is a vector quantity. Okay. Number three is nothing but the distance measured is always positive, and displacement can be positive or negative. That means it will have both positive value as well as the negative value. ठीक है ना? तो displacement can be positive or negative depending on the reference point, depending with the reference point. ठीक है? From where it has been measured. Number fourth is nothing but the total distance covered is equal to the algebraic sum of all the distances traveled in the different directions. That means we can have the algebraic sum of all distances traveled in various directions. But what about the displacement? The net displacement is the vector sum of the individual displacement in different directions. Okay. Again, there is always a distance that is covered whenever there is a motions, and displacement will be zero if the body comes back to its initial position. That means if from the starting point, if it is say matlab, if it comes back to the starting position, that means the displacement is zero. But here there will be distance, you know? There is always a distance covered whenever there is a motion. Okay. What about the unit for the distance and displacement? Is the both it has been measured in meters. Okay. Next is there is an example for this. There is what is the difference between a distance or displacement. Suppose you are observing an ant on the tables as shown in the figures. The ant moves from one corner of the table on the other corners. The blue irregular line shows the path of the ant. मतलब ये क्या दिख रहा है यहाँ पे? There is a zigzag motions, but this starting and end points with the help of this green arrow, it indicates the displacement. It has been the distance which has been traveled by an ant. ठीक है ना? तो आंसर क्या रहेगा? The length of this blue line is the distance covered by the end. The right green line, which is the minimum distance between the two corners of the table. That means in this zigzag positions, how to find out the distance? So we have to stretch a line from starting to end point. This will results in the finding out the that is the distance between the distance traveled by the end. Okay. Next is again important is the comparison between the speed and the velocity. Okay, na? Again important is nothing but the comparison of the speed and the velocities. How we can compare the speed and velocity with each others. So comparison of the speed and velocities. So here we can have speed is referred to how fast an object is moving, whereas velocity क्या रहेगा? देखो, velocity refers to the rate at which an object changes its positions. That means there is change in position of an object. ठीक है ना? Velocity is nothing but a change in positions. ठीक है ना? So change in position is nothing but the of an object is nothing but the velocities. ठीक है ना? Next is what is speed? Speed is nothing but a scalar quantity, whereas vector that is velocity is a vector quantity. ठीक है ना? Speed it has been measured in scalar quantities, and velocity it has been measured in the vector quantities. ठीक है? Speed is the rate of motion or the rate of the change of positions. Speed क्या रहता है? Speed is the rate of motion or the rate of change of positions. That means change of position is nothing but the speed, whereas velocity क्या रहेगा? Velocity is the rate of change of displacement. Velocity is nothing but the rate of change of the displacement. ठीक है? Again, speed is thus the magnitude component of the velocity. Velocity that is contains between the magnitude and directions is nothing but the velocity. ठीक है? Again, there are some of the differences for this. It has been measured in kilometer per hour. Same we can have the velocities because as scalar quantities, it will have the magnitude as well as directions. Next is what are the units of measurement? These are the units which has been used for in the engineering mechanics, because while solving the problems, these units plays an important role. This convergence plays an important role because it has been used for in various numericals. The units of measurement, the force unit is called as a Newton. That means it has been measured. The force it has been measured in newtons, and it is defined as a force required to accelerate a mass of 1 kg at a rate of 1 meter per second. That means mass into velocity. Mass into velocity is nothing but one mass is it has been measured in one. It has been assumed as 1 kgs, and rate that is the velocity 1 meter per second. So we can write down 1 Newton as 1 kgs and 1 that is meter per second. So 1 Newton क्या होगा 1 kg meter per second square, 1 kg meter per second square. The weight of an object is the gravity force which is exerted on that body, which causes it to accelerate down at the acceleration due to gravity. So we can write all the weights of 1 kg's mass. That means W is equals to what is weight? Weight is nothing but actually this was the related with the force which has been measured in newtons, but here it is nothing but the weight. Again, the weight it is nothing but the mass into gravity because it has been attracted by the gravity force of gravity. Okay, the force weight is equals to mass into gravity. Weight is equals to mass. It has been measured in 1 kg, and gravity is 9.81. Actually, it is 9.807. So weight is nothing but 9.807. That is in newtons. Why it is in newton? Because already we have seen kg meter per second square is nothing but the 1 newton. So we can replace this kg meter per second square into a newton also. We can write down here as newton also. Next, these are the again which has been used for that is the numericals, which that is the SI prefixes which has been used in the numericals. The that is giga, that is 10 to the power 9, mega 10 to the power 6 kilo, and so on. These are the which has been used for the various problems. Okay, what are the different fundamental laws of the mechanics? Because while studying the mechanics we have to deals with the laws, the different laws which has been taken care in mechanics. So we have to see the different fundamental laws. Okay, na? So sir, that is the Isaac Newton's. So according to his, he has invented in 25th of December, that is 1642, and he has been died in 20th March 1727, and widely recognized as one of the most that is influencing scientists of all the time and as key figure in the scientific revolutions. That means sorry, Isaac Newton, it has been the various laws, fundamental laws, it has been invented by this. Okay, na? This is nothing but the physicians, the various laws, it has been invented by this. Okay. So here, what is the Newton's first law? According to Sir Isaac Newton's, what is the Newton's first law? Because Newton's first law is also very that is important in this. So what is Newton's first law? Newton's first law क्या है? What is Newton's first law? An object at rest stays as that means it is at rest, and an object in motions stays in motions with the same speed and in the same directions unless acted upon by an unbalanced force. That means when the body is in motions it will be in motions, or when it is in rest it will be in rest when another force is unless another force it has been acted on a body, unless another force it has been acted on a body. Okay, so if it is in motion it will be in motions, if it is in rest it will be in rest unless the another force it has been acting on a body. Okay, this law is also called as the law of inertia. Also, objects tends to keep on going what they are doing. This is nothing but the that is law of inertia. It is also called as the inertia force. Also, okay? The motion of a kite when the wind changes can also be described as the first law. Okay? Is the example for the Newton's first law. Okay? Here there are the two examples for the Newton's first law. One when there is when a brake it has been applied on a moving bus, though it is in motions and some distance will be covered. Taken. So this is nothing but the Newton's first law. These are the two examples for the Newton's first law. Okay. What is Newton's second law? Again, sorry, Isaac Newton's. What is the Newton's second law of motion? ठीक है ना? So Newton's second law क्या है? The rate of change of momentum is directly proportional to that is impressed force, and it takes place in the directions of force acting on it. That means the change of momentum is directly proportional to impressed force. This is nothing but the Newton's second law, and it is in the direction of force. It will be measured in the direction of force. Okay? The force is equals to mass into accelerations. Okay? The force will be directly proportional to rate of change of momentum. That is nothing but what? But force is directly proportional to rate of change of momentum. Okay? But what is momentum? Momentum is nothing but mass into velocities. Mass into velocities. Okay? As mass do not change, force is directly proportional to mass is directly proportional to rate of change of velocity. Therefore, force is directly proportional to mass is multiplied with the accelerations. ठीक है ना? Force is directly proportional to mass into accelerations. ठीक है? So these are the examples. If a small force is applied, this is nothing but the motion of a ट्रॉली ठीक है ना. तो here this will explain the Newton's second law ठीक है ना. Force is equals to mass into accelerations. Now, the lesser the mass, the lesser will be the acceleration. That means the motion will be more. But here the mass it has been increased, the acceleration will be decreased. ठीक है. Again more force will be applied. ठीक है ना. Here we are increasing the weight here mass. Again this will results in extra force will be required for moving this. That is the this in a carriageway. Next is Newton's third law. What the Newton's third law says: for every action, there is an equal and opposite reaction. These are the two examples for this. In swimming pool, you can see here equal and opposite. There is a downward and upward reactions. So this equal and opposite reactions that has been stated by the Newton's third law. Newton's third law क्या बोलता है कि every action has equal and opposite reactions. Every actions it is having a equal and opposite reactions. ठीक है ना. So here is nothing but the when a force it is applied in a forward directions, the same way that is. It is having an there is an exertion force and opposite directions. ठीक है ना. These are the two examples for the Newton's third law. Again, what is the Newton's law of gravitations? Gravitation क्या है? Every body attracts the other body. That means the force of attraction between any two bodies is directly proportional to their masses and inversely proportional to the square of the distance between them. That means the square of the distance between them. Okay? The force of attraction between the two bodies is directly proportional to their masses and inversely proportional, directly proportional to the masses and inversely proportional to the square of the distance between the two bodies. So here we can have the example of these two bodies. These are the two bodies, serial number 1 and serial number 2 are the two bodies, and the separation there is the distance which has been separated. M1 and M2 are the two masses. So here we can, it is directly proportional to each other's. F is directly proportional to M1 and M2 and inversely proportional to D square. So here we can have the constant of proportionality as the gravitation, that is G. Okay, now this G stands for gravitations, constant of gravity. Next is principle or law of transmissibility of forces. Again, this is important related with the engineering mechanics. What is the principle of transmissibility of forces? ठीक है ना. Principle of transmissibility of forces क्या रहता है? The state of rest or of uniform motion of a rigid body is unaltered if the point of applications of the forces is transmitted at any other point. That means the force is acting at a point A, the same effect we can consider at the same line of actions. In the same line of action at this point B, there is the same effect. The force, the effect of force at point A is the same as the force effect of force at point B. The effect of force at the point B. So this is nothing but the principle of transmissibility. There is no change in the effect of force when it has been applied at A, but it is to be transferred along the same line of action. It is to be transferred along the same line of actions. Okay? So these are the examples for pull and push forces and principle of transmissibility. What is the law of superpositions? What is law of superpositions? The law of transmissibilities of forces can be proved using the law of superpositions, that is, which can be stated as the action of a given system of forces on a rigid body is not changed by adding or subtracting another system of forces in equilibrium. That means some forces is added or some forces is subtracted, so there is no change in the effect on the body. Okay na? So when it has been added or when it has been subtracted, so there is no as such change on the body. Okay na? This is nothing but the law of superpositions. That means force which has been force F, it has been acting at the point A. If it is along the same line of action, it has been transferred at the point B. That means by adding or subtracting, there is no change of forces. Okay, now here this is nothing but the superpositions or the concept of the law of superposition of forces. Okay. Next, again important is related with the engineering mechanics is the parallelogram law of forces. ठीक है ना? So parallelogram, as the name says, the forces are acting on the different sides of a parallelogram. the forces acting on the sides of a parallelogram, ठीक है ना. तो parallelogram law of forces क्या बोलता है? This law states that if two forces acting simultaneously on a body at a point are represented in magnitude and directions, ठीक है, when the two different forces which is starting at the same point and in the different directions by the two adjacent sides of a parallelogram, the resultant is represented in magnitude and directions by the diagonal. That means when the starting point of the two forces are same and they are considered by the two sides of a parallelogram, then by drawing the diagonals we can find out the diagonal of the parallelogram which passes through the point of intersections of the two sides representing the forces. Okay. So here, suppose the force F1 it is having a magnitude of 4 units, F2 it is having a magnitude of 3 units, which has been represented by the sides of parallelogram. The horizontal side is 4 unit, vertical side is 3 unit, and this diagonal is nothing but the diagonal which has been represented. Okay? So these are the four sides of the parallelogram in which, with the help of these two sides, it has been of the parallelogram. It has been represented by the forces. Okay. Next is derived law. What are the different laws considered for this? The triangle law of forces may be stated as if these are again the parallelogram law or the triangle law or the polygon law. So these are the different laws which has been considered. ठीक है ना? तो triangle law क्या है? The triangle law of forces may be stated as if two forces acting on a body are represented one after the another by the sides of triangle, as in previous we have seen by the sides of the parallelogram. Again here by the sides of the triangles. Again it has been represented by the sides of triangles. The resultant is represented by the closing side of the triangle. That means with the help of the closing side we can have find out the resultant of that forces, okay, which has been uh, 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 taken care by the two sides of the triangle. Again, the resultant is represented by the closing side of the triangle taken from the first point to the last point. So here we can have the example for this also, triangle law of forces. What is polygon law of forces? Polygon law of forces क्या है? If a number of concurrent forces acting simultaneously on a body are represented in magnitude and directions by the sides of polygon, ठीक है ना? In same way, by the sides of a polygon taken in order, then the resultant is represented in magnitude and directions by again the third side. ठीक है ना? It has been taken care by the magnitude and directions by the closing side of the polygons. It has been taken care by the closing side of the polygon. इससे क्या होगा? Closing side of the polygon से we can find out this, ठीक है ना? By the closing sides of the polygons, ठीक है? The magnitude and direction by the closing sides of the polygon taken from the first point to the last point, ठीक है? Next is classification of mechanics of solid bodies. Again, mechanics of that is the rigid bodies is nothing but the, as we have already seen in the starting slides also. There is statics and dynamics and kinematics and kinetics. So in broadly we will see or in statics and dynamics which things it has been covered, or kinematics and kinetics. Okay. What is statics? Statics क्या है? As I've already stated in starting slides that what is statics? Statics क्या है? So it is the branch of mechanics which deals with the particles and bodies at rest. When the forces acting on a body at rest. That means when the different types of forces acting on a body when it is at rest is nothing but the static. ठीक है ना? Dynamics क्या है? Dynamics is nothing but it is the branch of mechanics which deals with the particles and bodies are in motions. That means we are when the forces acting on a moving body, ठीक है ना? अगर body move हो रही है, what are the different types of forces acting on a moving body? We will study in the dynamics. ठीक है? काइनेमेटिक्स क्या है? काइनेमेटिक्स क्या होता है? तो इट इज द स्टडी ऑफ मोशन ऑफ पार्टिकल्स एंड बॉडीज विदाउट reference to mass and effect of forces, without considering the effect of forces is nothing but the काइनेमेटिक्स. ठीक है ना? अगर फोर्सेस को कंसिडर नहीं किया जाता है तो दैट इज नथिंग बट द काइनेमेटिक्स. ठीक है, विदाउट कंसिडरिंग द फोर्सेस कॉजिंग द मोशंस. ठीक है. Next is what is kinetics. Kinetics क्या रहता है? What is kinetics? It is the study of motion of particles and bodies with reference to masses and effect of forces. That means forces causing the motions? ठीक है, what are the different forces which will cause the motions? Sorry, the forces causing the motion, it has been taken care in the kinetics. So here we will consider the forces causing, okay, na, without reference and with reference. That means here we will consider the forces causing the motion in kinetics, and for kinematics without considering the forces causing the motions. Okay? Next is what is a force according to Newton's first law. Force क्या है? What is a force? Force is defined as an action or agent which changes or tends to change. ठीक है ना? Which changes or tends to change. ठीक है? Which changes or tends to change. ठीक है ना? जो मतलब which changes the position or tends to change the position is nothing but a force. ठीक है ना? So according to Newton's first law, what is a force? Force is defined as an action or agent which changes or tends to change the state of rest or of uniform motion of a body in a straight line. That means if it is moving in a straight line or if it is in rest, we are changing its state. We are changing its state. So this is nothing but a force. The force is nothing but which tends to change the state of body. ठीक है? Is nothing but a force. अब फोर्स का क्या है? यूनिट ऑफ फोर्स द ग्रेविटेशनल, दैट इज इन एमकेएस. यूनिट ऑफ फोर्स इज द किलोग्राम force and is denoted by kgf. The absolute SI unit of force is newtons and is denoted as capital N. Note 1 kgf is equals to g. That is, what is g? G is nothing but the gravity, acceleration due to gravity, that is 9.81, that is meter per second. Or what is, how many kgf or 1 kg is equals to 9.81, that is approximately 10. So 1 kgf is equals to 10 newtons. मतलब एक kg में कितने न्यूटन्स आएंगे? तो 1 kg is equals to 10 newtons. 1 kg is equals to 10 newtons. ठीक है ना? 1 kg is equals to 10 newtons. Next is what are the characteristics of a force? Again, very important is there. We have seen what is a force, and next is what are the different characteristics of forces. ठीक है ना? क्या है characteristics? What are the different characteristics of forces? ठीक है? तो characteristics of forces क्या है? It has four important characteristics which can be listed as follows. Magnitude है सबसे पहले, point of applications, line of actions and directions. So number one is magnitude. So it can be denoted as 10 kgf or 10 newtons. मतलब magnitude क्या है? Example में जैसे दे रहा है कि it may be 10 kgf or 100 newton, one and the same. This is nothing but the magnitude of a force. ठीक है ना? 5 newton, 10 newton, 20 newton. So these are the examples for the magnitude. Magnitude is denoted by that is 10, 50 and so on the newtons. That is nothing but the magnitude. What is point of applications? It indicates the point on a body on which the force is acting. The point at which the force is acting on a body. This is nothing but the point of application. The point at which force is acting is nothing but the point of application. It indicates the point on the body on which the force is acting. लाइन ऑफ एक्शन क्या होगा? लाइन ऑफ एक्शन क्या होगा? द एरो हेड placed on the line representing the direction represents it. That means arrow head जो रहेगा, that is nothing but the line of action. The line of action क्या रहेगा? Along which line the force it has been acting. ठीक है ना? The fourth is nothing but the directions. It is represented by coordinates or cardinal systems. Direction it has been measured, along which direction it has been acted, on which direction it has been considered. These are the some of the this explanation of a force. Here there is an ladder in which there is a 600 Newton weight. It has been acting at this point, and this is line of action. This example will, with help of this example, the different concept will be cleared. There is a horizontal floor is there and a ladder. It has been kept on a vertical wall, resting on a vertical wall and a floor. ठीक है ना? तो जिसमें there is a 600 Newton weight is there. Weight or a person is standing at the point C. तो magnitude क्या हो गया? 600. 600 is nothing but the magnitude. The direction क्या हो गया? What is the direction of this 600 newtons? It is vertically downward direction is there. The line of action क्या हो गया? Line of action. Wait a minute. 10 10 minutes के बाद. 10 minutes के बाद. Next is line of action. What is line of action? Line of action is a vertical, that is CD or C to D. Wait a minute. साइन करना है क्या सिर्फ? कुछ करेक्शन चेक करना है? मैं 10 मिनट से, ठीक है ना भाई, यहीं बैठा हूँ, मैं बुला लूँगा. Next is line of action is vertically downward. CD is nothing but the line of action is vertically CD, or C to D is nothing but the line of actions. Point of applications क्या रहेगा? What is point of applications? The point of application is point C is nothing but the point of application where load it has been applied. ठीक है. अब the magnitude of the force is written near the arrows. Magnitude it has been uh, written here, and line, the point is nothing but the line of action is arrows जो दिख रहा है वो line of action हो गया. Line of action is nothing but arrow head is nothing but the line of actions. The point of application is point C is the point of applications. So these are the nothing but the explanations of the that is the these things. Okay. Again, we can have the classification of forces. That is the force systems. That is coplanar, non-coplanar forces, concurrent or co-linear, or that is non-collinear forces, parallel and non-parallel forces, like and unlike parallel forces. Okay? So this force system can be divided into two main types. That is the coplanar forces and non-coplanar forces. Whereas coplanar forces, it has been divided in three. That is concurrent or non-concurrent coplanar forces, that is collinear or non-collinear that is coplanar forces, and whereas parallel or non-parallel forces. Again, it can, this non-parallel or parallel forces can also be divided into, that is like forces or unlike parallel forces, like parallel forces or unlike parallel forces. Okay. So these is nothing but the classifications of forces. That is, force system can be broadly classified into two, that is coplanar, non-coplanar, whereas coplanar is broadly classified into the three, that is nothing but concurrent and non-concurrent forces, collinear or non-collinear forces, whereas parallel or non-parallel forces. Okay. Next is, what is force system, or what are the different characteristics and what are the examples for this. Okay. So this table represents, or this table explains the different types of forces and what are the characteristics and what are the examples for this, which can be helpful for understanding. Okay. With the help of these examples we can understand it clearly the different force systems. Okay. तो नंबर वन क्या है देखो, फोर्स सिस्टम में कोलिनियर फोर्सेस है. What is the characteristics of collinear forces में क्या है? Line of actions of all the forces act along the same line. कोलिनियर का क्या मतलब है कि line of action उसका same है. The line of action of all the forces act along the same line. ठीक है. एग्जाम्पल क्या होगा देखो, फोर्सेस ऑन अ रोप इन अ टग ऑफ वॉर. दैट मीन्स जो टग ऑफ वॉर जो रहता है स्पोर्ट्स में, तो द फोर्सेस एक्टिंग इज नथिंग बट द कोलिनियर, बिकॉज द लाइन ऑफ एक्शन इज सेम फॉर ऑल द फोर्सेस. ठीक है. Collinear, the line of action of all the forces is same. Next is coplanar. What is coplanar? Parallel forces, coplanar and parallel. That means along the same plane and they are parallel to each other's. Okay? All the forces are parallel to each other's and lie in a single plane. That means they are in the same plane and they are parallel to each other's. What is the example for this? Example क्या है देखो इसका, that is nothing but system of forces acting on a beam subjected to a vertical load. When different forces acting on a simple beam, जैसे कोई भी एक concrete beam है, simple beam है, जिसमें different forces are acting which are parallel to each other. ठीक है. Coplanar like parallel forces क्या रहेगा? All forces are parallel to each others, lies in a single plane and are acting in the same directions, which are parallel to and like in the sense the intensity is same. ठीक है. Weight of a stationary train on a rail when the train is straight. That means the simple example, that is the weight of a train, because at the same the weight is same at all the points when it is in a straight position. Next is coplanar concurrent forces. क्या रहेगा coplanar concurrent forces? Line of action of all the forces pass through a single point and forces lie in the same plane. Coplanar concurrent. Coplanar क्या है? Along the same plane. Concurrent when the line it is acting and passing through the single point. What is the example for this? Forces on a rod resting against a wall. ठीक है. Coplanar non-concurrent forces क्या रहेगा? All forces do not meet at a point. When different forces they are not meeting at a point is nothing but the coplanar and non-concurrent forces. ठीक है. उसका क्या एग्जांपल है देखो यहाँ पे, फोर्थ इसका केस का, फोर्सेस ऑन अ लैडर रेस्टिंग अगेंस्ट अ वॉल व्हेन अ पर्सन stands on a rung which is not at its center of gravity. That means some intermediate, some distance पे it is acting, so it is nothing but coplanar but non-concurrent. Next is third last is non-coplanar parallel forces. Non-coplanar parallel forces. क्या है non-coplanar parallel forces? All the forces are parallel to each others, but they are not in the same plane. But they are not in the same plane. The weight of benches in a classroom. That means they are not in the same plane, but they are having parallel to each others. The same the benches which has been kept in a class. Non-coplanar concurrent forces, all the forces do not lies in the same plane because it is non-coplanar and concurrent, but the line of action is same. What is a tripod carrying a camera? Tripod, it is having the three various that is the legs are there, but starting point is same, that is concurrent point is same, and the legs are in different directions, ठीक है ना, different planes, non-coplanar. Non-coplanar, non-concurrent forces. So all forces do not lie in the same plane, and their lines of action do not pass through a single point. That means coplanar, different in different directions, in different planes, and in different line of action is there. Okay? The force is acting on a moving bus. Okay? When the bus is moving, and the force is acting on a moving bus. So these are the some of the examples for this, है ना, जो अपने we have seen in the table. So examples for this is nothing but this is nothing but the coplanar concurrent forces along the same plane, and they are concurrent to each other. That means they are passing through the same line, they are same point, ठीक है. Coplanar non-concurrent, that means there is a body is there, unequal body is there, and the force is acting on a body, ठीक है ना. नॉन कोप्लेनर पैरेलल क्या है कि एक प्लेन में है और दे आर पैरेलल टू ईच अदर्स, ठीक है. Coplanar non-concurrent, these are the examples for this. Coplanar parallel and coplanar non-parallel is there, ठीक है. Next is resolution of forces. These are the important things we have to consider. We have to resolve the forces. We have to resolve what is the effect of force when it is acting in some way intermediate. X में भी नहीं है, Y भी नहीं है, ठीक है ना. In some intermediate distance में when a force is acting, we have to resolve the forces along horizontal directions as well as along the vertical directions, है ना. This is nothing but resolving the forces along horizontal and vertical directions. How to resolve? What is the effect of force when it is acting some intermediate, है ना. X में भी नहीं है, Y भी नहीं है, तो intermediate में अगर force act हो रहा है तो कैसा उसका effect अपन we will carry on this effect, ठीक है. So it is often convenient to split a single force into two perpendicular components, that is vertical force and a horizontal force, ठीक है ना. Vertical force FV and a horizontal force, that is FH. Horizontal इसलिए we have given the name as FH, and vertical we have given the name as FV, and it is making an angle of theta because it is in some intermediate distance where it is acting, and actual intensity is capital F. The force intensity of this force is F. We are resolving this force F, which is making an angle of theta with horizontal x axis and vertical y axis. तो इसके लिए सिंपल क्या करो कि sin theta cos theta, what is sin theta? Opposite upon that is hypotenuse, and cos theta is adjacent upon hypotenuse, ठीक है. So with the help of this concept we can easily resolve this inclined force into two components, ठीक है. तो एफ एच क्या बनेगा देखो, cos theta. तो f is nothing but cos theta, and fv is nothing but the vertical component is sin theta. These are the some of the numericals related with this. Calculate the vertical and horizontal components if F is 4 newtons and theta is 35 degrees. So these are the some of the simple examples which can be used, which can be solved to with the for this problem. We can easily understand the concept of resolution of forces. तो एफ वी क्या है, एफ वी क्या है देखो. अब ये थीटा सिंपल वे में याद रखो कि इफ इट इज मेकिंग एन एंगल विथ हॉरिजॉन्टल, तो हॉरिजॉन्टल कंपोनेंट विल बी cos थीटा, और दूसरा जो रहेगा देखो यहाँ पे एंगल मेड नहीं है, तो दिस कंपोनेंट इज sin थीटा. एंगल जिससे बनेगा दैट कंपोनेंट विल बी cos थीटा एंड द रिमेनिंग विल बी sin थीटा, ठीक है ना. तो एफ वी देखो, एफ sin थीटा, एफ इज 4 साइन ऑफ 35 डिग्रीज, तो एफ वी कितना बन गया 2.29 न्यूटन्स. Whereas fh, that is horizontal force, is nothing but f cos theta, and cos 35 is nothing but 3.2. One thing it is to be kept in mind that the effect will be same total effect is 4 newtons, the effect will be same, addition will be same, that is 2.29 plus 3.28 will be same, that is 4 newtons. मतलब उसका क्या है कि only we are resolving into two components but its effect will not be changed, ठीक है ना. जो 4 था वही effect उसका horizontal और vertical में हो गया, ठीक है. Next is composition of forces. Next is important is composition of forces. The reduction of a given system of forces to the simplest system that will be its equivalent is called as the composition of forces. Composition क्या है कि we have to the different forces हैं उसको क्या करना है, उसको replace by an equivalent force. We are replacing the force into an equivalent force. We are reducing the different forces into a one equivalent force, ठीक है ना. This is nothing but the composition of forces. Resultant क्या है, resultant उसी से base related है. We are converting all the forces into a single force is nothing but a resultant force. Resultant force क्या रहेगा, resultant force, it is the possible to find a single force which will have the same effect. This is important, it is having the same effect of all the forces. जितने forces act हो रहे थे उसी का effect is nothing but the single effect is nothing but the resultant force. The same effect is nothing but the resultant force, ठीक है. So single force which will have the same effect as the number of forces acting on a body, such a single force is nothing but the resultant force, okay. Next, this is nothing but the composition of coplanar concurrent force systems. Again, this coplanar concurrent forces, this figure, this parallelogram figure is there. Coplanar concurrent forces. This will explain the concept of coplanar concurrent forces. The concept जो है वो this will be explained by this figure. Your force PQ is there and a resultant which is PQ and R is the resultant. This P is making an angle of theta with the horizontal, whereas alpha is the angle made by the P and Q forces, है ना. ये जो दो forces है उसके बीच में जो angle है, that is nothing but the alpha. So again the same way we will transfer this alpha, it is making with horizontal, so here we have transferred here with alpha in order to find out the component, that is composition of the two forces. Okay. So this is a simple that is the additions are there and the simple multiplications are there. With the help of this we can find out the that is the composition of forces, ठीक है ना. तो magnitude of resultant कैसे निकाले, देखो simple way में R is equals to square root of P square plus Q square plus 2PQ cos of alpha, because alpha is the angle made by the two forces, ठीक है. इसलिए क्या रिजल्टेंट कैसे बना, देखो R is equals to square root of P square plus Q square plus 2PQ cos of alpha. डायरेक्शन क्या है, देखो इसका, व्हाट इज द डायरेक्शन ऑफ द रिजल्टेंट, इट हैज बीन मेजर्ड विद अपोजिट अपॉन tan theta is opposite upon adjacent. तो ये here we can see the opposite side and adjacent side, ठीक है ना. तो here is nothing but Q sin theta upon P plus Q, that is cos of alpha sin alpha, that is Q sin alpha divided by P plus Q cos of alpha. This there is the different forces are acting on a grid. The different forces are acting in various directions along the south various that is directions. Yeah, this problem can also be solved. We have to find out the resultant force. We have to find out the directions of this resultant force. Again, procedure to find out magnitude and directions of resultant force. These are the different forces are there. The simple, we have to add all first we have to divide all the inclined forces into horizontal and vertical components, and addition of all the horizontal components and addition of all the vertical components. Okay? Or one thing it is to be kept in mind while adding this horizontal and vertical forces, right side is taken as positive and left side is taken as negative, whereas for vertical force upside is taken as positive and downward is taken as negative. So these sign conventions to be used while adding and subtracting the forces depending upon the angle made, ठीक है ना. तो depending upon the angle made, first we have to resolve along x and y directions, and whether it is moving right side or left side, है ना, positive or negative. So depending upon this we have to take the resultant. So resultant क्या रहेगा, देखो R is equals to square root of all fx square summation of all horizontal forces square and summation of all vertical that is forces. Tan theta क्या होगा, opposite upon adjacent, so opposite is y component and adjacent is summation of x components, ठीक है. Again, what is the movement? Movement is a force, that is the perpendicular force which has been applied while turning force which has been applied on any body, ठीक है ना. तो turning force जो apply होता है, that is nothing but a movement, ठीक है. turning force or turning effect of a force is nothing but a movement. Force movement क्या रहेगा? It is nothing but the force into perpendicular distance. One thing it is to be kept in mind: the force and the distance should be perpendicular to each other. मूवमेंट में क्या होगा कि दोनों एक दूसरे को परपेंडिकुलर रहेगा. हॉरिजॉन्टल फोर्स रहेगा तो वर्टिकल दैट इज द डिस्टेंस विल बी टेकन. वर्टिकल फोर्स रहेगा तो हॉरिजॉन्टल डिस्टेंस विल बी टेकन. दिस शुड बी परपेंडिकुलर टू ईच अदर. ठीक है. The year concepts we have covered in the today's lectures. Again, we will take our somewhat different concepts. We will try to cover it in the next lectures. Here we will end this today's lectures. Here we have covered the concepts regarding engineering mechanics. These are the very important things which we have covered in today's lectures. Okay? Here we will end this today's lectures. If anyone having doubts related with this, anyone having queries related with this, they can ask. Okay? So thank you everyone. Thank you. If anyone having doubts related with this, they can give this doubts, write down their doubts in the chat box so that it can be cleared for further things. We will cover somewhat different things also. We will cover the couple, what is the couple, what is the force. We have already covered the moment also. Again, the different we will try to solve the numericals related with the force systems also. What is the force system, how to find out the resultant of a force system, how it has been calculated. So we will see the different concepts related with the force system also. Okay, na? We will try to cover the equilibrium and frictions units also. Okay, so in this way we will end this today's lectures. Okay, so thank you everyone. Thank you.